Thank you, Lyrasis, for funding our project and providing us this platform to share our idea and get some community feedback. And we are extremely humbled to be part of this cohort of Catalyst Fund recipients. Congratulations, and thank you all for sharing some amazing presentations till now. Well, my name is Harish Maringanti, and he's Dhanushka. Samarakoon. We are here from University of Utah to talk about our project. We also have a couple more teammates, our rock star programmers, Brian McBride and Bohan Zhu, who unfortunately couldn't be with us today. Okay, the title is little cut off. 2 years ago, an article appeared on NPR with the following question: human or machine? Can you tell us who wrote these poems? The question was, can a computer write a sonnet that's indistinguishable from what a human can produce? Computer scientists at Dartmouth College, they set out to find an answer to this very problem. They designed an experiment that involved judges looking at sonnets and deciding whether it was written by a computer or a human. The results were not flattering. Or maybe flattering to humans, if you put it that way. None of the judges were fooled by poetic computers. They could easily make out who wrote what. But this inspired us to look deep and see whether we could use advanced image analysis, advanced image recognition techniques, and extract any useful data that we could use in the digital library. That is, could these machines produce enough quality metadata that we could use, which may be as good as what humans produce today? That was a cool idea, right? But we wanted to know if there was a problem here. And we thought, yes, there was a problem in our libraries. You know that structures that are built with bricks are strong, right? But it's a time-consuming process. It's back-bending work. So too, quality metadata. It is the bedrock of digital library systems. And without quality metadata, it is next to impossible to find any relevant data in this age of information overload. Creating quality metadata takes time. It takes experts who are trained in metadata schemas and metadata work. And not every organization can afford to have these trained experts or students assisting them in creating metadata work. And it is this very problem that we wanted to look at and see what we could do. So our approach was to see whether we could do something with machine learning. Over the past decade, deep learning, it's a method that uses layered machine learning algorithms to extract structured metadata from massive data sets. It has made unthinkable progress in many industries. Today, we see AI being used in risk detection in data centers, fraud detection in finance industry, to detect earthquakes, predict heart diseases, facial recognition, and many other innumerable inventions which would not have been possible otherwise. But deep learning requires massive amounts of structured training data for it to work, to train these algorithms. And guess what? Thanks to tireless efforts of metadata experts working within the GLAM sector, collectively we have access to tons of structured metadata in our systems. And we believe the time is right to deploy AI to solve some real challenges in our field. Dhanushka will talk a little more about our approach.
So what is machine learning? Machine learning, that's a field of artificial intelligence that uses statistical techniques to give computer systems the ability to learn from the data without being explicitly programmed. Let's take a look at well, I'm sorry, that slide is not working on the projector. But I'm going to talk a little bit on a process called model development. What we call model development is the process of training a neural network. In this example, which you can't see, you gather a set of images of cats, and what you do is you label them as images of cats, and then you gather a whole lot of other images of other animals and you label them as not a cat. And what you do is you submit these images to the machine, and what the machine does is machine converts these images into its mathematical representation. Then it uses its internal statistical formulas to understand what the mathematical representation of a cat looks like. So this process is called generating the model, and once this training is done, you can submit a new image to the neural network, and now the machine has learned what a mathematical representation of a cat looks like. So when you submit it a new image, the machine can go through those steps and tell you whether it's a cat or not. Now the interesting part here is, okay, your machine can identify cats, but what about dogs? In traditional programming, you would have to start, I wouldn't say start from the beginning, but you would have to do some work, some programming work to get it up and running. The important thing here is, if you want the machine to be able to identify dogs, you just submit it a new set of data of pictures of dogs labeled as a dog, and machine goes through the training process again, and then it knows how to identify a dog. Oh, there you go, you got a slim glimpse of the image. Okay, so now that you have learned the basics of machine learning and neural networks, let's talk a little bit on the project. We are doing a SWOT analysis of the project. So what are some of the strengths? We have some local expertise on machine learning. That's a big strength. And on top of that, we have an extensive collection of digital images with human-generated descriptive metadata. Similar to cats and dogs, we can use these for the training process. And the new workflow and the tools that are developed through the project, it can be easily integrated into the existing digital collection management platform. And what are some of the weaknesses? It is very difficult to measure the quality of metadata because it's dependent on the person who's doing that analysis. One person might say this is very quality metadata, if they are a subject expert, whereas a person who's not a subject expert but they are a metadata expert might have a different opinion. So this makes it difficult to compare the machine-generated metadata against human-generated metadata. There's no clear-cut answer. And in addition, the thought process is complicated and there's no standard approach to this problem. So what are some of the opportunities that we should seize? Like similar to giraffes, you shouldn't let these opportunities pass. The artificial intelligence and machine learning tools, they are now available as open source products. These are developed probably a decade back from companies with billions of dollars like Google, Facebook, but we don't have that much money. We don't have 500 million to invest in this. So instead of that, now they are available as open source tools. So now with the generosity of Lyrasis, the $35,000 is probably enough for us to start on this project rather than 500 million. So next time maybe we'll talk about 200 million. So this makes it a prime time to bring machine learning into the GLAM sector, as not much research has been done in this particular domain of GLAM. And it can contribute to the advancements of knowledge in the sector. What are some of the threats we are facing? So one of the biggest threats is the deprecation and abandonment of the open source tools we are using. One of the main tools we are using is Google TensorFlow. Google supports that product, but at a certain point, like some of the products, if it decides to deprecate the product or if it feels like they no longer have a business interest in maintaining the product, then we'll have to change course, we have to find alternatives. So that's one of the biggest threats that's facing us. In addition, the lack of diversity in the data set, especially the data that we use to train. Being an institute from Utah, the data is heavily from Utah, and the demographic is not that diverse. So this training data set provides a bias in training the neural network. And finally, the unknown unknowns. There's of course other threats out there that we are not even aware of that we'll discover during the project. Harish will talk a little bit more into the future of the project.
Okay. So, this is a quote from Dalai Lama. My colleague here, he loves it so much that he insisted on putting it here. But it goes to a point that John Herbert talked earlier. I think the title was Think Big, Start Small, right? So what we have is a very small idea. If you look at the overall workflow for a digital collections or a digital management system, metadata is one part of it, and what we are trying to do is just think about the descriptive metadata, what we can do. It's one tiny step. But we do hope that it will have a domino effect in how libraries think about this. For example, if this project is successful, the logical extension would be what we can do to automate metadata for moving images, for AV collections. Lots of universities have a lot of AV data. Digitizing them is the first step, but getting the metadata out of it automatically might help streamline some of the operations. So we hope that with this project we will be able to learn enough to see how we could start using AI in other facets of library operations, right? If you save time of our expert staff, you could perhaps reinvest that time in other big initiatives. So that is our hope. In concluding thoughts, as Dhanushka already pointed out about the diversity of the data, we know that this is going to be a challenging project. Again, our data is not perfect, idea is not perfect, and we know that a lot of big companies have stumbled before, especially when they embarked on AI journey, right? And there's a reason for this. There's a competitive advantage in doing things in secret for these companies. Luckily, we work in a non-profit sector, and we thrive on openness. And I think one of the things that we do want to do is start the project with the right intention and get community feedback as we go along. Again, we want to avoid these errors. Again, companies haven't done this with any malicious intent, but they couldn't get timely feedback in the right way. And I think this is exactly what we want to avoid moving forward with the type of data that we have. And we know that a lot of institutions have different types of data too, so we want to do all we can to get input as early as possible in this process and make sure that what tiny contributions we can make to the community, we can. The final thought, at the end of the project, we may feel that, or computer algorithms may just say that library data is too complex to understand and we give up. So there may not be any tangible results for us to walk away with, but we would have learned enough to talk about some potential collaborations and opportunities both within our community and with you all to see what else we could explore moving forward. And this is the final slide. This is just an image from our collection. This is some early results based on what we found out. So apparently the algorithm cannot differentiate between a paper or a newspaper and a laptop. So that is where we are. So questions?
Yeah, thank you. Questions, comments? I think you did a great job outlining, especially some of the challenges that you're trying to overcome. I think this is going to be so interesting to see as it progresses. Really, really interesting. Here, yeah, let's get through this.
What data are you using?
You mean, so data from our digital collections right now, we have 400 and close to 500,000 images that are described here. So part of the process is to set aside 75% of the data for the trade. So it's our internal digital collections data.
Okay, so we have 30 million objects for free with metadata at DPLA. I invite you to use the data and we will love to help you.
Great.
There you go.
Yeah, that's great. Thank you.
Your project just got a little larger. Your data set got a little larger. That's great. Other questions? Kate?
Do you have ways of combining the machine learning with crowdsourcing? So we have a Lyrasis friend who was from Colombia who did a project with Magnum Photos, and she did a crowdsourcing process where she had maybe as many as 50 to 100 people looking at each image, helping with some of the dimensions of the image. And you can imagine overlaying that with machine learning so that the interpretation gets better and better because it gets validated by a human.
Like correcting.
We do have
Go ahead.
we do have sort of a crowdsourcing model right now, but it's not developed with crowdsourcing in mind. It's basically a way for the users to provide feedback on each image on the digital collections platform. So it's not very high tech. If there's an image on maybe let's say a photo of the Utah football team from 7 years back. If someone's parents or grandparents are there, they can send feedback with their names, the histories to us, and we'll update the records. But that's not something, that's not the focal point of what we are doing. While I do understand that could provide a significant amount of data, if the users are interested, the level of interest from the users is the key variable here. So we are trying to find a happy medium where we can generate some metadata using the machine, more of trying to tackle the problem of quantity, while the experts work on the back end and at the same time use the crowdsourcing channels to gather more accurate descriptions. So I think it's the two ends of the spectrum. You have the quality and you have the quantity, and we are trying to find the right balance at a given moment in the timeline.
Great. Additional comments, questions down here? Yep. These are awkwardly placed steps.
So first of all, thank you for that description of machine learning. That was very well done. And also, I was wondering, this p-value, does it have to reach a certain number for the computers to sort of say, yes, this is it? And also, is that a standard in the industry or something you determine?
The p-value is more of the confidence rating that the machine generates. So higher the p-value, higher the confidence that the machine has on that particular description. In this one, most of them are pretty similar, except the last two has a laptop. So I think even though the laptop is there, the computer is less confident that it being a laptop. So that's why the p-value is low. So in terms of the final output, I think there is no set industry standard on what the p-value should be. It's something that we need to analyze and basically identify our own tolerance level to define, okay, this should have at least this much p-value for us to consider it as accurate metadata that should go into the platform. So it's more of try and fail approach to determine our tolerance.
Thank you.
Yes.
So given that you're using that metric to decide whether you think it's close enough to include, I wonder if you've also thought about a regular process where you would have metadata experts, or at least leading an effort to take a random sampling across the collection to look at every so often to see how you're doing?
Yeah, that's part of what we haven't included in the presentation. Right now we have a very rudimentary demo product that provides a basic interface. So a metadata expert can look at each photo. They don't have to go through everything. They can pick one in random, and the UI would display the photo and the metadata that the machine generated along with some of the tags. The expert can drag drop things, remove some certain elements, and fix the description if they feel like it needs improvements. Then we haven't decided how to approach that second stage of training. One main thing we can do is, okay, if it's the human generated metadata, it can of course go to the end product or the production platform. At the same time, maybe we can use that to retrain the neural network. So it's an ongoing process as and when we, like earlier what we discussed on crowdsourcing, as and when we get more and more accurate data, when you train the neural network further, it will of course get better. But I mean, there's a certain point that's called, I mean, I wouldn't get into it, but it's called overfitting, where if you train it too much, it goes off the rails. But it's about, again, finding that happy medium.
You mentioned that you were going to focus first on descriptive metadata. So I can imagine, for example, taking an image of a title page and being able to parse that into the proper metadata. Eventually, you see this extending into subject analysis, where you take the terminology on the title page and determine what the proper subject headings would be for that?
Yeah. So right now we have a massive collection of digital newspapers. We have a collection called Utah Digital Newspapers, and one of the unique things in our collection for the newspapers is we segment the articles, so everything is at the article level. John Herbert, he pioneered the UDN program while he was at Utah a decade ago. So right now we have over 22 million articles at the object level. One of the things that we are interested in is to see whether we could use NLP, the natural language processing techniques, to, we do have the data out through the OCR, even though the quality is not high. But one of the things that we are trying to do is improve the quality of the data that we can extract from these newspapers. And two, apply NLP to parse out entities. It could be people, events, dates, locations, that could add a semantic layer on top of the data that we already provide access to. So we are thinking about it. There are some tools out there that we could use. So it's still in very early stages, but I think that might be the next logical extension on how we can create these semantic layers on top of the data that we have.
Thanks.
To expand on it a little bit more, we have a project going on that is internally funded that's basically using the computer vision to improve the OCR. Because without improving the OCR, it's hard for us to run the NLP algorithms on the existing ones. So NLP will be a natural progression of that project during the second stages, but it's yet to be done.
Thanks. I think my question might be related to the last one, and I'll preface this with, as I often say, I'm not a librarian, I'm not a computer scientist, but I want to understand the bit I know we're talking like mark fields, right? Metadata, so there would be a series, maybe it's different, but would the machine learning at the end put out, like let's say you just got 5 unlabeled, unknown JPEGs or Word docs or something, or text files, and at the end of the process, the machine learning will auto-generate some candidates for certain mark fields? Is that what the principle at the end would be?
For this project, so we use Dublin core metadata, different schema, right? But the idea is structured metadata. So right now, what the machine is going to output, these would be keywords. The algorithms are capable of outputting captions too, but so far we have more confidence in the keywords than the captions. So how this would parse out is, if we are successful with the caption, this might turn into a title. If our metadata experts agree that this can go into the title, it could. Otherwise, the keywords would map into something else. So I think there is going to be a loose connection between what the computer is going to generate and how we are going to map it to our structured metadata. One of the other things we are thinking about is there is a lot of emphasis on controlled vocabulary in the libraries. And we are trying to see whether we could use some of the existing taxonomies and map it with the output from these programs so that there is less of keyword mushrooming. I mean, rather than keywords going all over the place, could we add some sort of control over controlled vocabulary? That's going to be an extension. I don't know if we can include it in the scope of this project, but something that we are talking about in our internal discussions.
Wonderful. Thank you so much. I think this has been amazing. Thank you.